Hi there, welcome to my channel. If you are new to this channel, kindly like and subscribe and turn on notifications for my new videos. Thank you and enjoy the rest of the video.
Alright, so let's check this question out. Okay, so the question says, when sodium hydroxide is heated with ammonium tetraoxosulfate 6, the gas given off may be collected by what? Bubbling through concentrated H2SO2, bubbling through water and then passing it through calcium oxide, passing it directly through calcium oxide, passing it directly through calcium chloride. Now, the first thing that we need to establish is that the first thing we need to find actually is that what was the gas given off? That's the first thing we need to establish. So now the reaction between sodium hydroxide and ammonium tetraoxosulfate 6, so that is NH4 2SO4. Now what is this reaction going to give us? Now this reaction is going to give us Na2SO4 plus NH3 plus H2O. Let's balance the reaction. So 2 at the back here and 2 at the back here. So I think that is balanced already. Yeah, by adding 2 at the back here. So that will be perfectly balanced. So this is the balanced reaction. Now Na2SO4 is a aqueous, NH3 is a gas, and H2O is a liquid. Now, of course, we already have our answer here. The gas given off was ammonia. Now, a very important thing that I need to tell you guys that you need to know is that whenever an ammonium salt and a base is reacting together, the gas given off is always ammonia. All right. The reaction of an ammonium salt and a base will always liberate ammonia. I'll take that again. The reaction of an ammonium salt and a base will always liberate ammonia. So just have that at the back of your mind. So once you have that at the back of your mind, you don't have to go through the stress of writing this reaction again. Once you know that, okay, sodium hydroxide is a base, ammonium, you are reacting with the ammonium salt, which is ammonium tetraoxosulfate 6 in this case. The gas that is going to be given off will be ammonia. Now, how can you collect ammonia in the lab now? Now, the correct answer to this question is C, passing it directly through calcium oxide. Now, how is this C, or why is this C? Now, the only gas that can actually dry ammonia in the lab is calcium oxide. That is CaO. It's also called quicklime. All right, it's also called quicklime. So this is the only drying agents that can dry ammonia. Ammonia cannot be dried by H2SO4. It's not possible. It's going to react with it. All right, they're going to undergo reaction together. Definitely, a base and an acid is going to give you a neutralization reaction. So it's the only drying agents that can actually dry ammonia in the lab is calcium oxide. All right. So another method by which you can use to collect ammonia in the lab is through upward delivery. All right, through upward delivery of the gas or through downward displacement of air. Now let me talk about that before we end this video. So now there are two methods of collecting gas in the lab. All right, so the first one is through upward delivery of the gas or downward displacement of the air, or through downward delivery of the gas or upward displacement of the air. So what I said was the first one, upward delivery of the gas or downward displacement of air. Let's talk about this first. Now, upward delivery of the gas or downward displacement of the air, basically. So this method is actually used for collecting gases that are less dense than air. What is the density of air? The density of air is 28.8. All right, that is the density of air. So now this method is actually used for collecting gases that are less dense than air. All right, that is gases that have lesser molar mass than air. All right, so what's the molar mass of air? The molar mass of air is 28.8 gram per mole. So this is the molar mass of air. So once you calculate the molar mass of a gas and it's lesser than 28.8, it means the gas is less dense than air. And if it is more than 28.8, definitely it means it's more dense than air. Now, what's the molar mass of ammonia? Ammonia is NH3. So nitrogen is 14 and hydrogen is 1, but we have 3 atoms of hydrogen here. So that would be what? 3. So that is 17 gram per mole. So definitely 17 gram per mole is lesser than 28.8. All right. So it means that the method that you're going to use to collect ammonia in the lab is what? upward delivery of the gas. That is, the gas is going to float on top and air will come down. That is why it is called upward delivery or downward displacement of air. All right, so that is it for the first method. The second method that I talked about was downward delivery. So the second method I talked about is downward delivery of the gas or upward displacement of air. All right, so definitely, what is this going to be? It means it's going to be for gases that are more dense than air. Don't forget the molar mass of air is 28.8 gram per mole. So any gas that is greater than that has molar mass that is greater than 28.8 is going to be collected through the downward delivery of the gas or the upward displacement of the air. So example of gases like this are SO2, O2 itself, CO2, all right, and the likes like that. So the molar mass of SO2 is 32 plus 32, all right. This is 64, this is 32, and this is 44 gram per mole. Okay, so these, of course, they are more than 28.8, so they'll be collected through what? Through the downward delivery of the gas or upward displacement of air. All right, so that's it about that. Now back to the question. So I think we understood why option C is the correct answer by passing through calcium oxide. All right, if upward displacement could not have been there, definitely, because you would have had two answers in that question like that, since both can be used for collecting NH3. So in that question now, I told you that whenever an ammonium salt and a base is reacting together, what do you produce? You produce ammonia, and ammonia can be collected by passing through what? Through calcium oxide, which is quicklime. That's the only drying agent that can actually dry ammonia in the lab. So that is the correct answer to the question. Thank you.